in the field, you are taking into account that they have an internet connection or not.
Yeah.
And because in some point I also work in something similar, and a typical question that people ask me is, and what's happening if internet is down?
So we are able to work offline.
I just move the question because I cannot answer, so I just move the question I didn't need.
Yeah. So the mute editor and the tool we are going to develop are able to work offline and online. So you could still work alone without internet connection. But the point is, in a disaster field, one of the first things people are setting up while providing resources, water, and so on, is communication. So we are more or less confident that there will be some access points where you could synchronize your data. And the other thing is that you could have also some kind of mesh network, you know, because we are able to set up communication from one computer to another, you know, creating an access point, a local access point, so you could have a small group working together without access to the full internet, but still they could share data from one device to the other. So this is what we plan to support. This is what we support.
Other questions? Do not hesitate.
I have many questions.
Start with the first one.
For the editor, mute editor, is it available on the web?
Yeah.
Okay, test it.
Yeah.
And in your answer to the last question to Teresa, you say that we can use it on offline and online.
Yeah.
How about the new version of the document? If each one work.
Yeah.
You need to have one version at the end.
No. Actually, every time you write, you type some character, it creates an operation. So if you're offline, you just keep all the operation. And then when you get online, you push all the operation to other editors. And then other copies, they receive the operation, and then they synchronize their operation. And what we guarantee is that once all the operations are synchronized, you have exactly the same version.
Okay, it's like a GitHub version server?
Except that we don't have conflicts. We solve conflicts. Sometimes it's not the best way. I mean, sometimes you will be happy with the way conflicts are solved. Yeah, it's a distributed version control. It's quite more or less the same, except we have the real-time dimension where you don't have to solve conflict if there is a conflict. There is no conflict. We solve every other concurrency issues thanks to the algorithm. And if you want some reference, I can.
In the architecture of open path product server, you mentioned API.
Yeah.
It's RESTful API.
Yeah. So,
RESTful.
but we were going to use WebRTC. So the big question is how you propagate operations.
Yes.
So what we are testing right now are gossiping algorithms. So we don't have to connect every computer to every other computer. So to have the operation going through the network with some.
Okay, thank you.
Thank you.
Other questions? I have several questions. The first one is that in your presentation, I feel that you make opposition between what I will call loose coordination and tight coordination, because for citizens they could have very loose coordination, I can interact or not and so on, but the authorities should have formal coordination. So we can't use, my point of view is that we can't use the same tools for different kind of coordination. What about your opinion about that?
So this is a debate we have in the team for a long time between people arguing for explicit coordination, so where everything is fine and you have to follow something.
And there are plans.
And plans, yeah, plans is more like a resource to help you decide what to do. And some about implicit coordination, where while you see what other people are doing, you decide a direction. You know, like on a football field, you see that somebody is running to the goal, so you may try to send you the ball, but it's not.
But loose is more is stronger than implicit, because, for example, the reversion crisis, you as a citizen, you can be involved or not. You can decide yes or no.
Yeah.
But when you say implicit, you don't say if it is obliged or not. Okay.
Yeah.
There is this nuance. So
This is why I said, okay, we have this strong vision of not having process design in advance and that we have to follow for this work. But I said also, okay, it's not sufficient. I mean, we need also, for some part of the action that you have to conduct, you may have process that you're kind of obliged to follow because
there is a responsibility,
there are some accountability and so I'm not saying
it's amazing.
VPN is not working.
No, it's not about that. This is a formalism. It is about the conception about what is good, because tools, the social media tools, are more for loose coordination and for citizen, and it can be made in opposition with the justice.
There's no opposition.
Another question is regarding the sharing of document. I wonder if is the document the real good artifact? Are they real situation where we exchange and we fill together documents? Isn't it maps, for example, as Ushaidi, you know, probably the tool Ushaidi, where a person puts resources, services, and requests in a map? Do you think really that documents are the very good artifact to collaborate?
Okay, so when we talk about document, so the example I took there are text documents, but it can be any kind of document. This is our goal to allow to share, you know, for instance, Excel files, images, maps. Maps is easy. It's easy to get collaborative map because you're not changing the same data with the. But what we saw is that people are actually using documents to organize, I don't know, weddings. You know, it's informal. They just add bullet points, and then everybody's saying, I bring cheese, I bring stuff, and I have a car. Who comes with me in the car? And you have a big document like that, and the people they can easily organize their action or their things like that, and they imagine a way to use them. This is something I want to study more, but they imagine a way to use collaborative editors or Excel file in a way very innovative. So this is not just to create documents, but I mean to create text.
No, what I mean that documents are not structured. For example, if you take the example of BlaBlaCar, which is a website in France to have a car to go to certain destination with a group and so on. It is structured. You have to fill some very important information where you go and so on. And don't you think that if you have a very free form of document, it could be a mess?
You should. So there is an example I did not mention that is very interesting to look at is Wikipedia pages, and especially when you look at Wikipedia pages related to a breaking news and events as it's ongoing. So there you have edition every 1 or 2 minutes of the pages. And when you look at all the pages, it's building itself, it's incredible. First you have very unstructured stuff, and then the page is creating itself. The structure is built by people.
The structure emerges.
The structure emerges through the collaboration of people, and it's not exactly real. Well, it's almost in real time. We looked at the Boston bombing page, and you see as the events unfold, the information being more structured with references to news media and so on as the information were produced. So it's very interesting to see how a group of people, not knowing each other, are able to create something useful and very well structured. And after one day, after 24 hours, you have a very well Wikipedia page, very nice Wikipedia page with all the information. So Wikipedia is interesting because people, they have reference about what is expected from Wikipedia, so this is easier for them. But I think this is very interesting to see how they are able to create that in almost real time as the events unfold.
Yes. Just a minute, okay.
The question I wanted to raise is, how do you tackle the issue of user requirements? Of course, let me try to explain it. The traditional issue is this. First responders, especially health people, especially medical doctors, look a little bit stupid. They are IT illiterate. So if you ask them for what their needs are, well, they formulate it in a way that is very difficult to interpret by IT people. Because they don't know what type of possibilities there are in IT. But secondly, IT people, I wouldn't say that they are deaf, but they have hearing problems, or they come up with solutions without listening to the problems. So you have this problem of difficulty in communication between these two sides, let us say. And often IT people then go to command and control people. Of course, that's the worst thing to do, because most of these command and control people are far from reality. And of course, command and control, you already raised the issue of command and control, planning, all these things. We use the let's say, analogy of musicians. For example, a jazz musician can improvise excellent if he has to perform. And so a first responder has to improvise, but that does not mean he improvised. He did not train and exercise days after days. So our IT and formal planning and structured interventions and protocols and procedures are very useful for training and education. But in the field, in the dynamics of response, you should be like a jazz musician. And improvise, based not on fantasy and arbitrary things, but on planning and training before. But I don't know how you tackle the issue of user requirements yourself.
Yeah, this is a very nice analogy. Yeah, this is really just, you know, the rules of music, and then you can play together. And this user requirements is a tough issue. And we try not to be just IT people, we try to be scientists. and so we try to go both ways, trying to anticipate on future way of working, like, you know, collaborative editing, for instance, was not something very natural for people. Now it's getting very natural. And then trying to go and speak with people, not just a commander. And so we had a lot of interviews with firefighters, trying to explain them what we wanted to do and try to understand what their problems. And knowing very well that the solution or the idea we could design could not get on the field right now. I mean, so this is a very iterative process. This is sometimes very frustrating because we think that we have very nice good tools, and we want them to use them right now, and they don't get the point really, and so growing older, I made my way with that. I mean, I know it takes time, for instance, to people to get, just like collaborative editing is now something, but I mean, a lot of people don't know about it, even today. Even in IT companies that have been working with people, they were not aware that you could do things like that even today, so it takes a lot of time. So we are trying to discuss with them. We are not doing what other colleagues do, like ethnographical study, going on the field with them, but we are reading that paper. But this is an interactive process, and this is a tough process because you cannot give them tools that would not be useful or that would forbid them to do what they need to do. This is what I say, more or less. Even if they have to be able to follow their own process and to decide for their action. And the process can just be a resource for their action and not something that forbid them to do what they need to do. If they need to do something at some point, improvise, they have to be able to do it. So yeah, this is tough. We need to discuss a lot with people from all kind of people to understand. But as you say, they don't know what is possible. So if we just wait for their questions, we're not progressing a lot. So it's tough, but it's very interesting and challenging.
We can thank François Charrois. We will.
Not the coffee break.
Yes. No. We will now have a presentation made by Serge Stingrich, and it was planned at the beginning in the session 4 of it yesterday afternoon, but we put it this morning since we have a gala dinner and so on. So the work will be presented is entitled "A Tool for Assessing Quality of Rescue Plans by Combining Visualization of Different Business Process Perspectives."
Very long title.
Yes.
So how much time do we have?
We will shorten the coffee break after, so to
Okay.
speak, the normal time.
Make some sign and try to stop. 20 minutes.
Yes, as usual.
Maybe where's the mic?
You have it.
Ah, sorry.
It's better. You have here, Serge.
Your system is complex. Huh?
Yeah, it's a complex system. Remember the talk of more 2 days ago? That's something like that.
So you are scientific, not the decision maker.
Okay, thank you for coming to my presentation this morning. So my name is Serge Stingrich. I'm an associate professor at Partie University, and I'm working in a lab called UBISCO. It's a lab that is, in fact, a joint research lab between IRD and the UPMC, so Partie University. So it's a joint work between lots of people. You see the title here. So it's mainly the work of 2 students of me and so Alvaro, who's a Colombian student from Chile University. It's co-supervised with me and Alex Berger. Le Nguyen Tuan Thanh, that is a Vietnamese student, PhD student that is co-supervised with Xiao. And we have 2 other guys, Alex, Xiao also, yes, Alex, who is a guy from the University of Chile, and Ho Trung Binh, that is a professor at Vietnam, Hanoi University. So my main point, position statement of this presentation is that we need visualization to assess the quality of rescue plans. It's quite a bold statement. I try to convince you that is a good statement. Maybe a few words of IRD and my lab before I start the presentation, because I think it might be interesting for you to know what is the IRD. So IRD is a research institute, it's a multidisciplinary research institute, and the main focus is to work with countries, developing countries. So we are around the world, especially in Africa and South America, and also in Southeast Asia. So for example, in my case, I spent 4 years in Vietnam from 2008 to 2012. So most of the IRD researchers are expatriates and they are working closely with partners in developing countries. UMISCO is my research team. We are mainly focused on complex systems. So that's simulation and modeling of complex systems, and we are doing lots of application. We are working on epidemiology, we are working on risk management, etc., etc. So we have lots of application. And you see some of our partners. So my lab is located in multiple places around the world. So we have Morocco, two labs in Senegal, in Dakar and Saint-Louis, in Cameroon and Vietnam also. And we have the main headquarters that is in the suburb of Paris in France. Okay, so the context of this work. So the first idea is that we want to work on rescue plans. So basically, rescue plans is something that are written by local authorities and establish the collaboration of the different authorities on the ground after the disaster or crisis. So they have to collaborate on the planning, the communication, on information sharing, etc., etc. And basically, most of the time, these kind of rescue plans are in fact available as textual documents. And it's quite difficult to assess or evaluate the quality of this kind of plans. Okay, so but it's very important to have such assessment of this plan, because if you want to improve them, you want to wait for the disaster. You want to have something. You want to be able to assess them before be able to use them in the ground. Okay, so they are quite difficult to analyze, and so the idea that we have since many years with the CHIA is that we can use business process modeling. I don't know if you know, who knows about business model process modeling? Only 1, 2, 3? Okay, thank you. So basically, it's something that comes from companies, from business. So the idea is to represent the activities of the company, of the business, by using process, and in order to analyze this process, in order to assess this process later. So for example, you have one example of this kind of modeling. So there's lots of formalism, lots of languages, and maybe you know some of them. Activity diagram, you can use battery nets, you can use, okay, there's a lot of them. And okay, so basically what you are doing with this kind of modeling, you try to identify the task, okay, the task with the relationship between the task, and you have some a way to model the choice, so the gateways between different parts in this kind of workflow. So basically, it's a workflow of activities. So what we are using is one of this language is the BPMN 2.0 standard. So it means business process model and notation. So don't be afraid by this size. Just put this slide to give you an overview of the complexity of this kind of modeling language. So basically, you have activities. You can model activities here, different kind of activities, tasks. You have different kind of gateways to link the flow between the activities. You have lots of possibility to model the events. So you see that without understanding all the details of this kind of language, you see that it's quite complex and it's quite rich also. Okay, so what is it? Yeah, so nobody speaks Vietnamese in the room, I guess.
Yes.
Is it Vietnamese? No. So, if you can read Vietnamese, you see here it's about the city, the tiny flood city of Ho Chi Minh, so it's south of Vietnam. And it's a Phuong Ham, so it's an announced report about from the U Ban Man Tan. I'm sorry about the pronunciation. My Vietnamese is still a little bit weak, and this is the People's Committee of the city of Ho Chi Minh City, because it's still a communist country, so they have a People's Committee everywhere. And so this is a report about sometime about this tsunami that might occur in the future on the city of Ho Chi Minh. Okay. So this is a report that we found on the net, because it's quite difficult to have access to this kind of documents. It's 40 pages of Vietnamese. So with the help of our PhD student, we have made a translation. And after that, we made a modeling. We model, it's not visible on my screen because I changed the resolution. But it's not really important. We find the model in the paper. So basically, we try to identify the different actors. Every lanes is a different actor, the police, the hospital, etc. And we try to identify the interaction between the different actors and the task that they have to achieve. So this is not the point of my presentation today, because there is a previous paper about that. So if you're interested how we do the modeling, you can read this paper that is, in fact, has been published at ISCRAM Vietnam. So we organized in 2013 the same event as this one, but only from Vietnam. And so you can find the paper on ArcSync. So the problem that we want to address here is how to assess and not only assess, but after that, improve rescue plans. So the idea is to use something that is coming from the software engineering field. The idea is to measure the quality of the process, and in order to be able to combine these different metrics and be able to assess this kind of process, rescue plans. So there are lots of perspectives that you can use for viewing your process. You can use process metrics, you can use simulation, etc. And so it's you need to find a way to combine this different kind of process quality, because that it's quite difficult to understand. And you need also to address the various phases of the disaster. Okay, so because the metrics, the process quality that you measure is maybe not the same in the different phase of the disaster. So what is the solution? It's very easy. So the idea is to use visualization and a tailored visualization, that is ad hoc visualization for different kind of scenarios or different kind of users. So these tailored visualization you will be able to combine them in order to assess different perspectives. And in order to do that, we have built a domain-specific language that we could use to describe the visualization of the process. Okay, and this domain-specific language is in fact available in the toolset that is the open source tool that we have built to assess rescue plan, that is called A4BP. Or maybe the name is not really, we have to change that. We have more sexy name later, but A4BP means assessment for our business process. Okay. In fact, it's not a tool for only for rescue plans. You can use it for other applications. Third, when you are doing visualization, what are the benefits of using visualization for doing assessments? The idea is that it's more easy for an user to assess the process visualization, and you can use some cognitive aspect of the visualization that are very nice. That, for example, you can see something that the visualization with pattern matching, and the idea is that you can view very easily the flows and the defect on the visualization. Okay, you don't need to understand the process. You just visualize, and you are able to do that. And what we want to do also is not to have static visualization, but dynamic one. Okay, because we want to shorten the feedback between the visualization and the modification of the model. And in order to do that, we are using explorable visualization, and I will explain a little bit more what our explorable visualization later. So this tool is available freely on the internet. We have the website here. It's an open source software based on Faro is a dynamic software language. It's available under a very liberal license, a MIT license. Basically, you can do everything you want with this kind of license. And so we have built lots of tools. We have no time to explain everything what we have done with this software, but you have BPM parsers, you have also Beeple. The Beeple is something quite similar to Beeple, but more for web services. Parsers and metamodels. We also have a BPC. What is BPC? I will explain later in the slide that BPC is like a new standard that allows you to do simulation of BPM model. And on top of that, we have some visualization, and we use the work of my colleague from the University of Chile, Alexandre Berger, that is a domain-specific language that is called Warsaw. And this domain-specific language is only for visualization, an agile visualization engine. I will explain later what we mean by agile. Okay, so we use lots of metrics, and because we want to visualize this kind of metrics, so we implement metrics regarding the static metric, regarding the process, so you can measure the number of elements. So basically, if you compare this kind of work with the work that you can find usually in software engineering, so the number of elements is the number of lines of code in the program. Okay, and the control flow complexity is you can find the same metrics in the work of software engineering also. We have also simulation metrics, so you can measure the time, the number of resources that we use, etc., the cost. And we have also, this is the work of time, we have also agent-based metrics. We are able to build from BPM process, we are able to build multi-agent simulations because we want to analyze the system from another point of view, from the organization point of view. So you are able to measure the efficiency, the robustness, and we have a paper that explains that in his reference at the end of the slide. Okay, so I will not talk about that. I will not only talk about the two first metrics. So just to give you an overview, what is the control flow complexity metrics. So it's not BPM, it's software. So for example, if you want to compare the complexity of this different kind of program, so you have a conditional here, so the complexity is in fact the number of paths from going from the start to the end. So here you have two paths, okay? So for this one is the same, the number of paths. So the complexity is 2, and this one you have a case with different choices. So depending on the number of choice case, the complexity can be quite high. So the idea is to have a measure of the complexity, a static measure of the complexity of systems. So this is for software engineering, but you have the same complexity measure in the case of BPM. So we implement this kind of measure. For BPSIM, so BPSIM, we have also implemented a basic BPSIM simulation engine inside our tools. So BPSIM is a very huge standard. So it's a standard that is quite that has been built on top of BPMN. It's quite recent, and it's huge. And the idea is that you are able to describe scenario. Is you describe the time for each task, you describe the distribution probability for the task, you describe the resource that you will use, etc. etc. So it's quite difficult to explain. And at the moment, this standard is not supported by most of the tools. So the tools that you can find on the web, for example, to Bonita-Sort, all these model of BPM models too, they are not supported at the moment. This kind of BPC extension of the BPM standard. So we have implemented a small portion of this standard inside A4BP. Okay, this is the basic architecture of our tool. So we are basically we use this language also to do the visualization, and we are able to, in fact, load, import BPMN models. So, in fact, if you want to design your process, you have to use an external tool like Bonita-Sort, okay? And after that, you can import these models inside the A4BP. And for BPSIM, in fact, there is no support. So we have built a small domain-specific language to build the simulations, you know. Okay, so a few words about Rosso, because it's very, very important to understand how it works. So the idea of Rosso, so this is the work of my colleague. The idea of Rosso is that this is a tool, a language to build domain-specific languages in different domains. Okay, so for example, if you want to build a visualization language for graph, okay, with Rosso, and I will not explain the technical details how it works exactly, but with we are able to different kind of languages. For example, with another PhD student, we have built a domain-specific language for epidemiology. Okay, so we are able to describe for epidemiologists, not computer scientists, we are able to describe a model, and we can. So the language is quite easy to understand even for epidemiologists. They just describe the model, and after that they can do simulation and visualization at the same time, very easy. Okay. So this is another example. Another example that you may be more technical in the domain of software engineering. If you want to visualize test coverage, okay, when you are doing software, usually you have to do unit test. A good way to build software, and you want to know if your software, the coverage of the software, the cover enough or not. And so you have this kind of visualization that will give you some information about the way the tests are doing. So you see that this software is not that much test. And what is interesting is that you have feedback. So every time you modify the software, the visualization automatically is updated. Okay, so the visualization helps the decision maker to take decision in this domain. Okay, so for each domain you can build a specific visualization with this kind of tool. So this is what we have done for business process modeling. And oh, it works. Okay, so this is a demo of how it works. So because it's important to see. This is visualization, so you have to see something. Okay, so for example, you see here we build visualization with numbers 1 to 10. Okay, so you have instant feedback. So you run the visualization and you see immediately what the results. You can modify the grid or the layout of the representation, and after that we can do something more elaborate. So instead of using numbers, we are using classes. Okay, so each square is a classes, and after that, the video is 7 minutes. I'm cut before the end. So for example, we want to change add some information, because here you have gray boxes, but you have no information about each class. So you want to modify the size depending on the number of methods inside the classes. So you see, it's a very explorable visualization. You want to see your model, because here you have access to a model that represents a class hierarchy of an object-oriented programming language, and you can very easily visualize something, a connection, for example, between the class. Okay, you see, so it's quite complex, but maybe after that we change the layout, because usually if you want to represent a class hierarchy, you usually use a tree layout. Okay, you see very immediate feedback between the end user, the guy who use this language, and the visualization. Okay, to change a little bit, another kind of. Okay, we will stop here. You have the basic idea. You can see after the presentation, if you are interested, I can show you some demos. Okay, so the idea also is to be able to build custom visualization tools. So the idea is to build custom analysis. Okay. The idea to provide domain-specific knowledge for each domain user. So come back to the main topic of this talk, the crisis or to assess crisis scenario. So this is basically what you could do with our tools. So you do process modeling. You have two layers. So this is a BPMN model. So you have two layers: the designer of the process and the guy who represents the authority, and the model process. After that, you have different kind of modeling, multi-agent modeling, process modeling, and you can evaluate the process. You have different kind of evaluation, and you combine the assessment with the visualization, and after that, you analyze, you get the result, and you have a feedback. Okay, so this feedback is usually quite long, so we want to shorten this feedback by using this kind of agile tool. This is a screenshot of tool. I will show you a video at the end of the talk that is maybe more interesting than the static screenshot. So basically, you have here can explore different kind of models that are available. Okay, you select what you want to do, simulation, execution, etc. The perspective that you want to view, and here you have the visualization and the different kinds of metrics. So you have predetermined visualization. So if you don't want to use the language, the domain-specific language to build a tailored visualization, you can use the predetermined visualization. Okay, just click on the button. But if you want to build a more elaborate, more ad hoc assessment, you need to use the language. Okay, so in the paper you will find two examples of the assessment that you can do with A4BP. So this one is so we use the HCMC, the Orchard City business process, and we have a visualization here where we use what we call a polymetric visualization. So basically, you represent all the tasks as an example, And each rectangle you can have three metrics. So you have a matrix on this part, another matrix on this one. So for example, this is complexity flow control matrix. This is another one. And the color can be used also to represent something. I don't remember. This is a number of relations. Okay? So at the same time, you have something that combines different kind of information in the same visualization and represent also the relationship between the different blocks. Okay, so you can do that very easily with the language, and you can modify the methods that you want to view very easily with the language. Okay? So you see here that maybe here there is a problem, because this box is very, very huge. So the complexity, the CFC complexity and this complexity is very huge. And the color means that there is maybe too much relation, okay, compared to the other box. So maybe there is a problem here, okay. I'm not an expert of crisis management, but maybe there might be a problem here. So you have to look at this problem. Another possibility is that, for example, here you see there is 2 times the same patterns. Okay, you see this box with the smaller one on the bottom. So maybe there is something that is redundancy here. Maybe you should also examine why you have 2 times the same pattern. Okay, so by using this kind of visualization, it's very easy to detect this kind of flows or defects. And another example of visualization, so you will find the details about this visualization paper, and also with the script. I don't put script here. You can find the script are inside the paper. And here the same, but you have 2. In fact, you represent 2 information, 2 visualization at the same time, and there is a link between the 2 representations. For example, when you select one of these box here, immediately you know in the other representation, you know, you see the same box in the context of this representation. Okay, and you see here you have a chronogram. And here, if I remember, we want to visualize a simulation metrics. Okay, so metrics with regarding the processing time and regarding the quantity of resources that you will use for the activities. Okay.
Okay, you have to conclude.
Okay. So
Let's just see the.
Yes, I have a short demo. Okay, so we load the tool and we select, we import one deep model from files. Okay, so this is the Optimum City visualization, and after that we have a hierarchy of process. You can do predetermined visualization of the element of this process, relationship between it's a bit fast, but basic relationship between the ID. So you see, this is the process. You can have the standard view. Just want to stop, no? Possible? It's too fast. Here, sorry. That's something here, somewhere here, okay. Okay, here you see this is the basic standard view of the BPM process. Okay, the one that we have seen at the beginning of the presentation. Okay. And you can also do animation. So if you do simulation, you can see where all the flows works in fact. Okay, just want to see the end. Okay. Okay, the one that we have seen during the presentation. You can zoom, you can. All these facilities are provided by the Russell infrastructure, and nothing to do regarding Okay, that's it. Okay, next one. Okay, conclusions. So in the previous presentation, François tells us that maybe BPMN is not maybe the good tool for maybe a model crisis, but I think with the help of it's more easy to assess the quality of the process, of the script process. Because one idea also of using BPMN is that if you want to be accepted, this kind of thing is going to be accepted by end users. The idea of using graphical artifacts is quite interesting. But at the moment, what we are missing is that we need the validation by the end user. Okay, so if you are interested by this kind of tools, you have some examples, and we can try to work together in order to have a more accurate validation. Some perspectives. At the beginning of the talk, I said that the BPMN 2.0 is very complex. So maybe we have to move towards a domain-specific business process. Maybe we have to provide something that is more related to crisis. Okay, so a business process formalism that is in this domain of crisis. We might imagine some other applications. So if you go outside the room, there is a poster from me and another colleague from Senegal, and we start to use BPMN to model epidemiological surveillance systems. But we can use also the same kind of tool for humanitarian supply chains also. We like to thank our sponsors because we have lots of people who help us in ENEA for providing all the infrastructure for building the tools. So Google, because they help us, they found us one students for building all the mathematical library that we are using. Okay, Profile is the company that is owned by my colleague from Chile University, and ISCRAM is the association that helped us for funding Alvaro to come in France for 2 months. Okay, thank you for coming. Any questions?
Okay, 1 or 2 questions. Questions, the maximum. You have questions?
Yeah.
Yes. Short question.
You gave me the one not working.
No.
Oh, yeah.
Red.
Red means working. So I'm going to ask the question we agreed upon.
Yeah, thank you.
Well, I think it's important to have kind of visualization of process validation, notably the complexity and so on. But I may have missed the question of interaction validation. What's the impact of raising for the, well, just say it's syntactic, of course, check, but you don't have the semantic check. It's always difficult to obtain to see if the process is valid. You can have analysis and maybe identify this point may be difficult because that's low or process too complex. But it is a global process that I don't know how you, just like an activity diagram, you mix up the process and the interactions. So you may not have, I haven't seen it, maybe I've missed it, the interaction part to check.
What do you mean by interaction?
Well,
Interaction between
the business process is centered on the proper process.
Yeah.
But who is executing the different tasks is not specified, or it's or is it? As you have a GL system to validate that, check consequences.
Yes, as I already told her, we didn't validate too much with end users, so yeah, so yes, we have to do that if you want to address the real concerns, yeah. Yeah. And I'm not really an expert in business processes, so interaction. Do you mean about the semantics? So how we validate the semantic? That is
both of them.
Yeah.
Semantics and also
I agree that the here is mostly about we focus on syntactic aspect. There's the complexity and maybe we have to provide maybe the metrics regarding the organizational aspect that will be maybe more interesting in order to validate this kind of concern. Yeah, but I agree with you. It's at the moment it's mostly focused on syntactic issue. Yeah.
It's kind of funny. But how to explore?
But you know, this is the same in when you are doing this kind of when you use this kind of visualization for software engineering. It's the same. You know, mostly focus on syntactic aspect of the system.
Another question? Even if I am co-author of this
You want to ask
paper,
something?
not a question, but to go the same way. Perhaps what is not shown here is once we have transformed the model in a more explicit one, what to do with. We don't have shown, because it is in other papers, the metrics, for example, organizational metrics and other things. What to do with this once we have transformed this, but it is in the other one of the paper you have
I
mentioned.
cite many papers. You will find the end of the paper.
The indicators and the... Okay, thank you very much, Serge. Okay, now it's time to have coffee break, rapid coffee break. Alors, qu'est-ce qu'on fait là? Voilà, c'est ça. D'accord. Non, non. Question, merci.
En fait, on voulait augmenter oui, mais là, on peut expérimenter, soit ils ont oui, par contre, mais ça devrait. C'est ça, ça fait un peu peur. Ça devait créer. Il n'y a pas de normal, mais ça reste assez. C'est comme le centre de vue, on voit ça, c'est vrai que j'adore le voir. C'est vrai que on fait à l'ensemble. That's because of the language. Yes, yes. Les solutions que j'aimerais appliquer, c'est pas forcément ce que j'avais.
Faites le break, comme ça. Go to the break.
Oui,
François, everybody, come on.
Les formes de parallélisme, on avait, c'est vrai qu'il y a l'idée, c'est quand même d'être proche de BPM. Peut-être que c'est trop proche de BPM. Ça veut dire que en fait, ce serait plutôt utilisable par un analyste, quelqu'un qu'on se rend compte. Et c'est peut-être pour ça qu'il faut qu'on aille vers plus vers un outillage qui serait lié un peu le métier de l'agence. On a proposé à notre collègue, les lectures. En fait, j'ai pas le temps d'expliquer le langage, mais en fait, tu dois pouvoir dire quels sont les éléments qui t'intéressent. Ensuite, tu dois pouvoir construire rajouter les métriques, c'est-à-dire la couleur, et faire les relations, et le layout, c'est-à-dire ce que vous voyez, c'est sur un cercle, c'est dans un arbre, c'est des emplacements avec des forces pour placer de manière. C'est basiquement les trois. Le métamodèle, il est ça, c'est view, layout, et je ne vais pas expliquer, mais en fait, c'est ça. En fait, il y a une sorte de métamodèle du langage. Il y a toujours ces
Après, c'est capable d'utiliser ce. Oui. Dans la première phase que tu as, c'est un beau scénario. Sur lequel ils sont.
Ouais, ça a priori, ce serait possible. Ça compliqué le chose. Je vais pouvoir faire plusieurs visualisations en variété par un. Ouais, bah, tout est possible.
Ah, mais c'est pour ça, c'est marqué.
Je viens.
Je regardais à quoi ça ressemblait
Bah oui, hein.
ici.
Et c'est pour ça que je suis venue là rapidement. Je me suis dit, devrait être pressée pour voir sa présentation. Donc, c'est la première.
Ah, ok. Vraiment bien. Ça va pour les
Vous êtes rassurés maintenant. Donc là, vous êtes étudiante en doctorat?
Oui, ça me commençait, c'est un mois.
Ah oui. Non, c'est bien.
Mais c'est pas vraiment ça là, justement, c'est pas trop avancé, c'est pas une...
D'accord. Ok. Bon, vous en faites partie. Donc,
Oui, j'ai fait avancer dessus, mais j'ai pas vraiment commencé.
donc là, votre étude.
C'est à Lévis, c'est au nord de Toulouse.
Pas vraiment.
C'est avec Frédéric. Sur le même projet, j'ai une option de...
Plus c'est votre première visite.
Ah oui,
En Tunisie.
Merci.
C'est vrai qu'on a passé presque une année pour tout préparer. Ni pour tout, ça et tout.
Très bien, moi j'aimerais avec plaisir.
C'est parfait. Si vous aussi, si les gens qui sont
Avec
peut se dire
j'ai parlé, oui, j'étais contente.
on y va.
Très bien. C'est la première fois.
C'est la première fois que on va une session en Tunisie. L'année prochaine, on sera
Pour faire le côté de la vie. Comme ça, on fait du village. On arrive en Grèce. Non, c'est bon, j'attends, ça va. Vous pouvez continuer la pause si vous voulez. On n'a pas connecté les revenus, on va faire ça. C'est ça que je me dis.
ouais, souvent, les gens vont prendre leur demi-heure, apparemment, parce que normalement,
Ils tiennent, confirme. Et puis c'est très très bon aussi. Mais j'aime beaucoup les petits feuilletés là.
Ah ouais?
Ça n'avais jamais mangé. C'est une spécialité d'ici.
oui,
Ouais.
ben, on le fait à la tunisienne.
D'accord. C'est très bon. Je ne saurais pas dire ce qu'il y a dedans, mais c'est très bon.
Yes, all set?
Yeah.
Okay, good.
Ready.
Good luck.
Thanks.
I will try to ask you a few hard questions.
Oh no, please. Don't do that.
Yes, okay. Let's break up a bit.
Okay.
She will do the same.
Yeah, I will take a review.
You don't have much time for that. You got time the next one. And you also can't present it. Yes, you can put everything in future work. That's true. So, what is the name of Matthew's lab? Olby?
Oui, une mine d'avis. Et le laboratoire, the laboratory is the Center of Engineering Science.
Okay, because I wanted to say the name, but I don't know.
And the axis is the axis of organizations interoperability. Yo. And so in front, it's the laboratory CG and the department Yo.
Okay.
I don't know if it's.
But I will tell that you can contact Matthew. Matthew's lab, yeah.
جماعة كل لاباس عادي رسيل وإلياس وجماعة كل أنا مازلت في الكونفيرونس دونك عندنا لي بريزونطاسيون توا باش نبدو وأمك طلبتني ما نعرفش يمكن ما نحبش باهي هاني بديت من بعد باش يصدقوني.
Yes. Yes, sure. Yes, but the model is changed a bit, so I think the figure is not the same. But you can, I think, it will remind you. Okay. Yes, it was about the shelters for the finding shelters. This shelter system. I'm not sure. Yeah. And we are also down next to support, right? So the same.
Was very good to use social media.
Yes, that one is also interesting. But it's interesting that when we say social media, then we are always Twitter. Okay, then we can say Twitter, not social media.
It's a bit because always when the people present stuff about Twitter, one of the future work is perhaps we could try to work on social media that nobody does because it's too complicated.
Yes, yeah. Sometimes I think it's impossible because of the privacy options that are there. So.
I've programmed a few tools to prepare results on hashtag on both Twitter, Instagram. I was using Tumblr and Flickr.
Yes, but it doesn't work because they're private.
No, it works with those because they all have the kind of same openness.
Oh yeah.
I didn't include it for the presentation.
Yeah.
Working with the API of Facebook is just something that outside. I've been working a bit with YouTube API too. But the fact is, when you try to do such comparative work, it's sometimes a bit difficult because they don't represent the information the same way. For example, there is no concept of tag in YouTube.
Yeah, there is no. Yes.
So, well,
you have to look for keywords over there.
Yeah, but keywords are not a thing on Instagram.
Yeah.
Instagram is more focused on title. We are trying to compare stuff that don't work the same way. It's a bit.
But can we use it, for for example, 3 approaches and then combine these 3 approaches together. I mean, we can use keywords for YouTube, and we could use hashtags for Twitter, or we can use
keyword search, text search, instead of hashtag. There is no hashtag.
Yeah, but then you are comparing stuff that are not exactly the same. And on some social media, like Twitter, you can use both search by keyword and search by hashtag. But still, it's possible, but you have to be careful to know that you are comparing stuff. I want to
what is the, what we have to consider, what do we want to know when we are using that kind of search. So if you are looking for data, then what is the difference between the data which are driven by hashtags or the data which are driven by the keyword search? What is the difference? What?
That's particularly.
Yeah, I know, but
Yeah.
For example, the difference between searching by hashtag and searching by keywords is what people do when they use hashtag. But for another example, if you use hashtag, is saying I want that my tweet belongs to such a conversation.
Yeah.
And it's they are not using hashtag for every word. They are using hashtag for some specific topic they want to they want their tweets to be linked.
Yes.
But
Maybe they want to do the same in YouTube, but they don't have the option.
Yeah, but in YouTube you can say that all the words in the description of the video that's the same way.
Yeah.
And there is no such description. Only grabs by using the shape of
Yes.
C'est plus cher, non? So,
Hi everybody. So welcome to the last session in ISCRAM MED conference. This session is about decision support systems and collaboration. And we have the 3 presentations. The first one is will be done by Audrey Fertier, then Hussein Baharman, and the last one will be done by Jurt Seyman. So, Audrey, you can begin your presentation, which is about towards the support to stakeholders collaboration during a Loire River major flooding.
So, hi everyone, my name is Audrey Partie, and I'm a first-year PhD student in the French Engineering School in Belgium. Today, I'm going to present to you the article entitled Lifestyle Manica toward the support to stakeholders collaboration during the Loire River major flooding. This is a case study based on the Loire River flooding. And this study will enable us to observe and find the problems faced by the stakeholders during such a crisis, and then propose them a solution to help them collaborate. So, this is the Loire River. It is the longest river, and it rises, like you can see, in the southeastern part of France, and flows along 100 kilometers through cities like Saint-Etienne, with the football, I don't know if you know it, Orléans, with the castle, and Nantes, with wine. So this is a studied era. It is the Middle Loire era. And you should know that in France, we are able to forecast waterfalls over 6 days. And water level along all the Loire River over 4 days. So the Middle Loire era is divided in 5 valves. A valve is an area protected from small flooding by tides. So we have the Val d'Amont, the Val d'Orléans, Val de Blois, Val de Tours, and Val de Tours. This Middle Loire era is also divided by 5 administrative counties era. The lower administrative era in France is the counties era. So we have them here. And you should also know that in France we have 3 levels of alerts. We have the safe level in green, the warning level in yellow, and the critical level in red. So thanks to governmental simulation tools, we have been able to simulate a 1/50th per year flood, the one we have studied. And its mean, this total means that it has 2% chance of happening per year. So we have the evolution here, and we can see that the first day, only 1 bar is in yellow alert. That means that some evacuations are beginning to be made on the most risky areas. And then we can see that the stakeholders, we will respond to the crisis. We have to face 5 days under. We have to face 1 day with 4 or 5 bars under red alert, and 5 days, consecutive days under red alert for at least one of the bars. This is almost 300 kilometers to cover for them. So it's huge, and they need to coordinate to be able to do that. So these stakeholders can be represented at the local level. We can find in such a crisis 23 kinds of different stakeholders, from administrative organization, from governmental organization, from private organization or institutions. And we have, for example, the supplier, the electricity supplier, the EMS services, the police, the firefighters, or the road services. This is the personal level. And like I was saying, François, there are observability issues to face on the ground. So to help them face them and to take decisions, a processor is set up as a county level. And we have 1 processor for each county involved in the process. So here we have 5 county levels. And because it is the first step of the level, sorry. And because there are several, we put in place a processor at the zonal level for each different zone involved in the process situation. So we have 2 here. And then, because there are 2 zones involved, we have a processor at the national level. So all those entities has to communicate in order to coordinate. And they communicate by following a peer-to-peer chimney. And that means, in reality, nowadays, that it's hard for them to have the right information at the right moment. We call all the problems due to interoperability problems on the ground, the horizontal distributions issues. And all the issues faces by the processor to communicate between them by push forward informations and take back instructions, the vertical priority issues. So besides all those coordination problems that we can find between the stakeholders, we will face the interconnections between backbone networks. For example, if the electricity lines are down, the stakeholders on the ground will lose the lightning, the telecommunications, and if they will face complexity factors like health issues due to the water drinking transformation. But if they want to put back electricity, the power supplier will need both the road and telecommunications to put it back. So we face a vicious circle that will need to be break by the stakeholders. Here you can find all the cascading effects due to the loss of one of the backbone networks. And we will need coordinations between stakeholders to be able to break the vicious circles due to these interconnections. So, what do we know? We have a large hierarchy cover. So we will need several administrative hierarchical ladder to do that. And then we have several stakeholders who are heterogeneous. So it will be hard for them to communicate on the ground due to semantic problems, for example, or acronyms, and between devices styles of different zones. And then the interdependencies between networks will oblige them to coordinate themselves and coordinate the teams on the ground. But to do that, they lack of time, so they focus on the crisis response and did not take care of the collaborative issues that they have that they are facing. So the idea is to resolve the coordination issues by supporting the decision making inside the crisis cells. And because the crisis is a complex system, and because of the critical timing and the the fact that the crisis can evolve at whatever moment, we also will be obliged to automate the adjustments needed by the ongoing developments in runtime. That is important. So this is raising two questions. First, how to collect and gather the real data, and then how to automate the adaptive collaborative process. So, if we were the supervisor on the middle here, what we will have to do if we have the time to support this collaboration? First, we will have to gather data from the ground, and then, thanks to that deduce a collaborative process by deducing it from the capacity of the stakeholders on the ground and the data that we have gathered. Then we will have to implement it, and some people will have to ask the different stakeholder services to do the different tasks that they have planned. So after that, during the running of the collaborative process, all supervisors and the mentors will have to monitor the situation by following some alerts, which can be calculated alerts or visual alerts. And when they find the time right, they will be able to adapt the collaborative process. by implementing a new one, all in one time. And then we will have to call the text one by one again. So, how can we free this man of the middle? We will do that by automating all of this process by using first the service-oriented architecture and using an enterprise service bus with its orchestrator that will be able to call the task one by one by following a loose coupling chimney. And this means that it will be far easier to have the right information at the right moments for the different stakeholders and the different supervisors. Then, thanks to the event-driven architecture, we'll be, and by using complex event processing, we'll be able to automatically create alerts by following Python rules like that, and send a message through the internet to the maintaining services of the ULP, and then the maintaining services will be able to automatically adapt the collaborative process, which is running on the ground by the different stakeholders. So, this architecture that I just showed to you enables us to support a mediation information system, and I will present to you how it is operating. So first, we have to gather the data from the ground. And then, thanks to, I don't know, to connections between the different data, we will be able to create a situation model of the situation. And then, thanks to overall connections, and thanks to our knowledge of the business rules of the stakeholders involved on the crisis situations, we will be able to reduce several collaborative processes. This is the defining phase. Then, the decision makers will have to choose one of the collaborative processes, and we will have to implement it by transforming the collaborative process into workflows executable by the orchestrator. And then the orchestrator of the USB can ask the different services to do their jobs. And then, while the process is running, we'll have to supervise the ongoing developments by continuously gather data from the ground. For example, and if the situation is not like we have predicted, like here the road is flooding by one rider, the stakeholders on the ground will have to send a message to the USB. Then the USB will be able to update the models of the situations and say it's not like we predicted. So the mediation information system will adjust the collaborative process to decrease the gap between the situation model and the expected model. And then we'll be able to send another message to the ground to say, okay, no, you have to turn around and take another road. And then all the stakeholders that will have to go to the transformer here in the middle will know that the road is blocked and that they can all take another road to go there. But they have to take another road to go there. So, we have a country being cut into by the Zoar River. So this is hard to avoid for the stakeholders if that's the wrong side of the river. We have 5 days under red alert along 300 kilometers, plus 1 day with forward on the other 5 which are in red alert. So this means that it's hard to, if the timing of the crisis is critical. And we have to face two types of coordination issues, the horizontal one between the stakeholders on the ground and the vertical one between the crisis staff. Oh my God. It's a can.
Crisis to be managed.
Ready for it.
Emergency. What is the process?
Okay. Sorry. And then, because of the interconnections between the different backbone networks, we have to make the crisis stars collaborate and to be so that they can be able to coordinate the stakeholders on the ground. So we propose to use both event-driven architecture and service-oriented architecture to support the mediation information system. And then we'll be able to define a situation model and implement a collaborative process. And then continuously adjusted with the ongoing developments, with the analysis of the ongoing developments. In the future, with the increase of the different heterogeneous sources of information, we'll have to enhance the data aggregation and the data filtering inside the complex event processing in order to avoid the stakeholders to be drawn under data informations, especially in the processors. So thanks for your attention. If you have any questions.
Thank you, Audrey. Yuki.
Thank you, Audrey, for your presentation. Are there any questions? No question? So I have a short one.
Okay.
In the step of gathering data, right? So what tools are you going, or you think you are going to use? I mean, social media, or maybe you have collaborators, or?
For the moment, we are using only data from the fixed database, from the stakeholders' knowledge, from the knowledge of the ground for the use case, like this. But my PhD work will be based on the ability to gather data from social media too, and other sources that are not fixed in the time. I'm sure that we will look into that. That's why I'm starting my PhD.
Just a small question. Just, Audrey, in your title, you were much more focused on this study and more river flooding. In which extent your work will be applied to other cases than this case study, or which are you do you think that you will give solutions especially for flooding or for other disasters also? To which level this is specific to this case? What is the genericity or?
This work has been applied for other crisis situations in the past with different projects. And my PhD work is included in the genetic project, which takes, for example, only flooding. And we are working on the 150 barrier flooding. And we are also, I don't know, we want to also take, for example, 100 barrier flooding. But it's more difficult because the data are far more difficult to find.
Do you think that it may be which parts, or do you think that your work may apply to other disasters?
Oh, yeah.
Or what is specific to flooding? Where flooding can influence?
Nothing except for the data at the basis of those studies.
Okay.
Simple.
So, thank you.
Got one, but it's too shiny to ask.
Okay, so thank you again.
Thank you for your
The next speaker is Hussein Baharman, who is going to talk about the literature divergences of the humanitarian supply chain.
If they wish, PDF file.
As the member of the organization team, we would like to ask all authors, if they can, and speakers, if they can send us their presentation so that we can put it on the website. Thank you.
Yes. Okay. Hello, everyone. Thank you for being here. My name is Hussein Baharman, and I'm a PhD student at the University of Agder. I am also a member of CM, Center for Integrated Emergency Management, at the ICT department of University of Agder. Today I'm going to present a paper about the gaps in the literature about humanitarian supply chain. This work is done also with Laura Laguna Salvador. She's a PhD student at the University of Toulouse. And of course, Tina Gomez and Matthew Loros, I think you already know them. They are our supervisors. So first, I will go answer the question, why do we need to study humanitarian supply chain? First, I think we need it because we want to have more effective and efficient response. And to answer the question again, why do we need that? We have to consider the quick rise in the number of disasters every year. And also, this quick rise has followed by not that much increasing in funding sources. So here we have a gap between the funding and what we need, the appeals. Humanitarian response is very complex field because in response we can see different actors with different expertise, with different knowledge, and all. So when we want to study humanitarian response, we have to consider different disciplines. The combination of authors with this paper allowed us to pick two disciplines and study the humanitarian supply chain regarding these two disciplines. One is business engineering science, and one is the operation research. The difference between these two viewpoints is the way that they look at the supply chain, or exactly, I should say, explicitly, humanitarian supply chain. When we talk about business science, this field is trying to have a holistic view on supply chain and then try to align the processes together and then have optimized chain. But operation research is different. In operation research, we decompose the supply chain into small problems. Then we can model those small problems, and then we can have optimized solution for that. Since we are going to hear humanitarian logistics in this presentation a few times, then I'm going to discuss a bit about that. As Van Wassenhoff said, the logistics is the main part of the response because it makes difference between the successful one and the failed one. And that's why that's why the researchers are very interested in humanitarian logistics. In humanitarian logistics, we mainly deal with efficiency and effectiveness because we want to deliver scarce resources to the affected people in a timely manner, and also we want to be cost efficient. So decision makers in humanitarian logistics, they are trying to make vital decisions right after the event of the disaster, but they have to consider their limitations, and also they have to consider the pressure that they receive from media, from the affected community, and from the organization headquarters. So they are facing a lot of challenges. We can see that in humanitarian relief organizations, they are mainly focused on getting the job done. So they want to just do the job, and after that, they will say, okay, how did we do it? And that's why we think that they do not care about performance measurement. That's why we think that we can use ICT solutions for that, and then we will discuss it in future slides. Okay, so we discussed why we choose business science and operation research because of the background of the authors. So to find out which domains we have to look, which categories we have to look in, we tried to review some survey papers, and then we found out 4 main categories that are frequently repeated in these papers: the structure, the flow control mechanisms, the time frames or time steps, and the dynamic uncertainty. So then we formulated our research questions. What is the state of the art in humanitarian supply chain, referring to these 4 categories, and what are the future research directions? Okay, now we begin with the first one, the structure. In business science view, the humanitarian supply chain includes all processes beginning from sourcing and then end up with last mile delivery, or what we say. So it covers a lot of logistic processes also. But it's very different in comparison to commercial supply chains. For example, if you consider demand, we have highly unpredictable demand in humanitarian supply chain, but you can say in commercial part, they are more or less predictable. So if we want to apply those approaches that we found for commercial supply chain to humanitarian one, then we have to be careful, because if we focus more on the commercial solutions, then we will lose our goal. We want to be effective more than efficient. But we have to balance these 2 objectives together and find a solution for that. As Serge presented previously, the application of commercial process modeling in supply chain, as we studied, is very limited. So we are looking for new approaches that and also the use of simulation of processes. Then we can track the ongoing processes during the response phase. We have different time steps, so we want to know what happens in each time step that we are going to define. From the operations research viewpoint, we mainly found out 3 problems, the sub-problems. Facility location, which is about where should we locate our facilities, I mean houses, distribution centers, etc. The distribution problem, how should we reach people, from which way, from which routes, by which mean, I mean airplane, plane or helicopters or something. And the inventory decision problems, because we have very scarce supplies, then we have to be very careful about them, because we want to distribute relief items which are mainly needed by the affected people, and we have to be very careful with them, with inventory management. So, all these survey papers said that although we have a lot of modeling efforts and simulation efforts, but we do not see much progress in real field. And that's why they are suggesting that we need ground-up research. For example, if you can see the left side, this is schema that is prepared for a model. This is the before field study. You can see the local distribution centers and multiple trips or single trips, and also the way that we want to distribute items. And this is after field study. This field study is done in Nepal. So we found out there that we don't usually see these local distribution centers in the chain, and we may also use different kind of transportation, I mean porters, during the response phase, which should be considered in our modeling approach. For the flow control, we have mainly 3 types of flow. We have financial flow, we also have information flow, and the last one, or the main, not the main, but in part for the method. The events of who is doing what, where, when. So the information is the first priority of the decision makers. And we still have a lot of problems in response because of the lack of information during the response phase after the disaster. This is for performance measurements of the humanitarian organization. We have much information. What we are looking now in information flow is to find out business performance indicator. We have comments like K performance indicators, KPI, but they are not applicable to humanitarian supply chain because of the differences between these 2 chains. And also the role of business science can be in developing software for humanitarian supply chain management. The one that we have many ones. So we can say this part, financial flow and the information flow, is more covered by business science. And the OR is looking at material flow, which we want to maximize the material flow in our supply chain. during the response after the disaster. But we are faced there, and a lot of challenges happen. Maybe we are facing zero lead time. It's not a vegetarian supply chain because we cannot provide it. Also, the model case in the humanitarian supply chain because of a lot of risks over there. For example, the infrastructure failure, and also the material convergence, which is highly seen in every disaster. Search, and you can see this challenge everywhere, and we combine these together. We can see that if we find out a good performance indicator, which shows the condition of the material in our chain, it can also be used in business science for performance management. And that's a key in this category. The other category is time frame. Mainly in response after the disaster, the event of the disaster, you see that we have a response. People, organizations, and they are going to the field, and also it's about saving people life, and also it's about logistics, because logistics mainly cost 80% of the response. And the media coverage is huge, so everyone is looking at the field. And business science tries to divide the response phase into three sections. The ramp up, I mean, when a lot of people are going there, so we have a rapid response. Then we reach sustain after 2 weeks, 1 week after the disaster. So we are doing the response until we reach a point that on the next month we will leave the field. So that's we ramp down. So if you consider these three time frames, we are agility at the first part to the leanness. Sometimes we can find a phrase for that, agile. So the main concern in business science, according to time frame, is to find a agile system. The system can handle both agility and leanness. Because if we focus only on agility, then we are considering more effectiveness. If we are focusing on leanness, then and we need a balance between these two things. In OR, operation research, the models are mainly single time, so they assume that we are looking for a temporary network configuration. So they just want to make a network configuration for one, let's say the first day or the second day. They do not consider the changes during the different time steps. For example, we can say that the first week of the response is really different in comparison to the 6th week after the disaster. So objectives may become different during the response, during the different time frame, about effectiveness and efficiency. And we think that if we try to develop a multi-period and multi-objective model, then we can enhance the response and we can have a more realistic models for humanitarian supply chain. The final one, dynamic uncertainty, is mainly because of the unpredictable events after the disaster. So lack of efficiency and misalignment of the response and the two main topics. Business science suggests that we can go in this category with short-term forecast and prediction, and also we can focus on the beneficiaries' needs instead of focusing on other objectives. And also the simulation of a humanitarian supply chain system can be a great help. Therefore, if we combine all together, we need a decision support system that enable decision makers to have a vision of the ongoing situation of the response. Exactly in the, not exactly, but the same. Similarly in operation research, we are looking for stochastic modeling because we want to use these uncertainties to help decision makers. We want to have different scenarios, to consider different scenarios, and then help them to simulate their situation. So we found out that we need ground-up research in both business science and operation research. We need some performance indicators that can help both two disciplines. We need to balance the objectives, and we need a agile management system for that. And we need to include stochastics and uncertainties in our decision support systems. This is the summary. We define 4 categories, and then we find out the research directions. So this paper have resulted in 2 PhD projects. I am working on one of them, the integrated distribution plan, which is more OR, operation research, and the other part is on the process by Laura. So in integrated distribution plans, we are going to consider 3 problems together: location, allocation, and transportation. So just a brief description of the problem. We want first to know where should we locate our warehouses and other facilities. Then we want to know how to allocate these resources, the scarce resources, to that warehouses. And then we want to transport these resources to the affected people and affected area. So these 3 problems are going to be considered together in an integrated approach. And then for sure we will use a stochastic and dynamic approach, because the literature is highly demanding these 2 approaches. And also the model parameters are going to be driven by field study, like the one that I had in Nepal. So then we can say that our model is based on more realistic parameters and assumptions. And also the constraints are more realistic. This developed model can be part of a potential decision support system. This is a potential decision support system. You can see it was proposed by Ricky and the others. So you can see what they were supposing is a first network design, and then allocate resources, and then they will go to distribution plan. So they take 3 steps. What you're doing is to integrate all of them in one problem, which can help decision makers, and also it can also help because it's more time efficient to be solved. The other project, PhD project, which is Laura's PhD work. She's working on a decision support system. She's working more on operational decisions. Operational decisions are the decisions are about the decisions that are made previously in tactical and in tactical phase, for example, when we want to distribute items. So we want to reflect what we have decided in the reality. So what this decision support system will do is to reflect those decisions in real supply chain and then see what happens. She's trying to find data sets, and she is also doing that from IFRC, and she will see what happens after her study. And also, this decision support system will be a direct connection with my model, for instance. So they are very related to each other. Yes. And please contact us if you have any recommendation and any suggestion for these two topics. You have our email address. Also, we have a laboratory, disaster resilience lab, which is mainly handled by Tina and Basil. And minus Alve is about Matthew's lab, and CM is the Tina's lab in University of Ireland. So please have our email addresses if you want to contact us. And then I think I'm ready for your questions. Thank you.
Yeah, thank you, Hussein. Any questions? Yes,
Thank you very much for your very nice presentation. At the last slides, you talked about stochastic modeling, and was wondering what kind of formalism or mathematical tools you want to use.
Okay, we have now. I have also actually I should say, because it's my part. I have now tried to first prepare the model by deterministic parameters. I have not yet decided about the stochastic part, but for the deterministic part, it's already ready and it's working. So it has been tested a bit. But for the stochastic, I'm not still sure, but I'll see.
For the deterministic part, what are you using?
We have actually I have used. If you're asking about the programming language, okay. So first it was implemented on MATLAB, and then I transferred it to AIMMS. It's a kind of academic language which use different solvers like Simplex, GAMS, and everything together. But the main structure is based on Simplex. Simplex, yes. It's a mixed integer problem.
Thank you for the presentation. I'm working on recursions. So this raises a lot of questions. I didn't get first what you want to do. This is your problem, is to compute the solution or to find a better solution. Give an example of sending computation, so I guess you...
Yes, since this project is going to be on ICT department, we are going for only theoretical mathematical modeling.
It's not my problem. My problem is not that. My problem is not what kind of model. It's, are you looking for a method to compute the solution, or are you looking for a method to improve, or have a resilient organization, or because if you're looking for computation, okay, operation research, a lot of tools for that, a lot of models for that, and supply chain modeling, and interesting engineering. So just the only difference finally between general supply chain and this kind of approach is, of course, it's not that important because lives are more important. But if you look to be able to see your first example, you scheduled to send cars, and there was a landslide, whatever. So you have to go by feet.
Yes.
So you have to find a recovery plan.
Yes.
This kind of approach is closer to repair scheduling.
Yeah.
Meaning you try to repair a planning.
Yeah, that's it. We want to improve the.
So that was my question. Do you consider a third solution, and you want to,
which can be prepared, or like instance, so
which can be prepared before the crisis, before even after that, because after the study can mean during the crisis or after the crisis, lots of factors.
Okay, you can use this one. Yes.
Thank you. So you can have repair scheduling approach, which consists, for example, of micro modification. For example, you have operation like transport with subclasses, and when one is failing, you may try to use another one and compute a new cost, and etc.
Yeah.
So if you're looking, so the question is either to validate robustness of a solution, because you want to check what happens if this event occurs. Is a plan endangered, or okay, it costs a little more, but it's okay, it's working.
Yeah.
So it can be done before the crisis, or it can be to manage the crisis when you have a solution and you want to take into account information from the field, and you want to change the plan and apply and see the consequences. So in one point, it's a validation tool of your supply chain, and the other one is just a decision support, a real-time decision support. Not exactly the same objective, but the same question in both cases. You try to produce a solution, or to validate the solution, or to improve, not in an OR approach, because improve a solution in an OR approach would be a better solution. But this is just a crisis. You just want another solution, maybe not efficient, but it's still working because you have to transport goods to some place and other. So if you're looking for that kind of approach, repair scheduling is interesting. And you can look at a lot of works based on the agent-based simulation. Because agent-based simulation can be, of course, seen as a validation tool, an implementation solution, because you put it as a tool approach, but it also can be a modeling approach.
Yes.
For example, when the question about the tool was asked, I could have thought about maybe any logic, if you know the element, kind of object-based model. You describe object with behavior, you press play, and you see what's happening. It can be agent or not. So you can have agents either as a modeling, conceptual model, and agent as a software testing level. So it depends what you're doing.
Okay.
But
Thank
you. Just look at repair scheduling and use some paper.
Yeah. Thank you very much. Yes.
Okay, thank you. Are there any other questions? So thank you again, Jose.
Yeah, thank you.
The next and the last speaker for this session is Jill.
Yeah, station.
Sandy. who is going to talk about a position paper on improving preparedness and response of health services in major crises.
Okay, good afternoon. Well, almost noon. My name is Geert Sijmenhaven. I'm a medical doctor with a background in disaster medicine and toxicology from Brussels, Belgium. First of all, I want to thank the organizers for giving me the opportunity to present this project and for the excellent organization. Of course, I don't want to spoil your lunch or your appetite, so I will rush a little bit through the slides. So the slides will be a little bit complementary to what you can read in the article, and we'll focus a little bit on the health issues involved, because you're all very clever people. I'm sure we can rush through this, but I will raise the issues at stake, so the challenges that we're confronted with in this project. So the outline, the goal of the IMPRESS project. The IMPRESS project is an FP7 research project. I will present to you what we call the conceptual framework behind it and the scope of the issues involved. I will briefly give you the architecture and the components of the decision support tools that we intend to develop. I will try to illustrate it briefly by giving you a workflow in a mass casualty incident scenario. Just to elaborate, I will briefly present to you the earthquake case and that we are going to test in real life, and I will give you the opportunity to comment and question. Of course, if there's something that is not clear, please feel free to interrupt me or to comment immediately if there's something that is not really clear. So the goal of this IMPRESS project is to develop a decision support tool for improving preparedness and response of health services in emergency situations. So the focus is on health. We're not focusing on other emergency support functions like fire or police or other functions, but our focus is really health. And if you look at the goal, to put it politely, diplomatically, these goals are extremely ambitious because they pretend that they will be used for operational coordination, will be able to be used in plan indication, training and exercises, and also to be used to record, report and evaluate. You know, if you look at this, this is a black box where you can solve all problems in emergency situations. So of course, this is extremely ambitious. So we would be pleased if we could implement a number of these issues that we pretended to solve. So there is, of course, if you look at it, a certain granularity, an increasing amount of detail in the approach that we have. First of all, and that is extremely complex from my point of view, from the health point of view, to explain is the conceptual model in how to deal with health emergencies. To explain this to medical doctors is already difficult, but to explain this to IT people is extremely difficult. So the core conceptual framework, even after a year, the people who develop the different modules are struggling with the concepts. We pretend that we can develop an analytical framework that is generic, that is usable for all types of emergencies that you can dream of. Because we have an approach that describes the pathogenic and the salutogenic factors that influence positively or negatively of the health of a community. And then we go into much more detail, and so we would be glad if Impress would be able to solve some problems to do with what we call one side of the medal, which is a mass emergency situation, like a mass casualty incident. So we have a mass casualty incident resource management tool that is able to deal with specific types of incident linked with trauma. And we have also the possibility of a major accident with hazardous materials. On the other side of the scope of health emergency are things that are much less known by medical doctors, by the general public, by IT people, which we call public health emergencies or public health crises. I will go into that too, but we think that with the generic approach that we have, we can cover both extremes and everything in between. So then we have a number of scenarios that we are going to develop in real time. And then, of course, there's the question of validation and evaluation of this approach. So to start with, let me introduce you a term that looks to you extremely difficult, but is actually very simple. The scope of the project is everything that other people call disasters or major accidents or mass emergencies, of all these things that they mix and that they define badly, what we call extraordinary public health challenges. These are challenges that have impact on the health status of a community and can have an impact on the health services. So all these situations require a specific extraordinary approach that we call a disaster health or disaster medicine approach, which is something different from the routine approach that medical services have. So there are two major challenges in these extraordinary public health challenges. One has to do with what we can call a disproportion between, on the one hand, the needs, the health needs, or the way they present themselves, and on the other hand, the response capacity. So actually the problem is a problem of resource management. That is rather an easy problem. Well, it's a difficult, a complex problem, but it's quite known how to deal with this. The other one has to do with another type of challenges that have to do with information, inadequate information, deficits, uncertainty, controversy, with respect to the nature, to the scope, to the causes of a specific problem that threaten the health status of a community. That has to do with how can you support this type of difficult decision making. So many events, incidents, accidents, processes, threats can lead to these extraordinary public health challenges. And that's the core of our conceptual concept. That is the binomial core, health status, immediately linked with health services. And you have, of course, a dynamic and continuous interaction between those two. So if you look at this slide, on the left side, we see factors that we can call factors contributing to the problem, to the pathogenesis. And on the right side, factors that help solve the problem. So, for example, and that is the danger, a lot of people try to limit the problem to public health risks or public health hazards, which is a very simplistic way of trying to approach public health. And others forget often public health enhancers, promotion of public health, and of course, the response of the health services themselves. So we have public health as a level, the health of a community, but of course this community is made up of individuals, and all these individuals are different of course. So if you look at the scope of a project, it has to do with public health determinants and population health, not with individual health situations. So this is, of course, very dynamic. The status of the health of a community is dynamic, it's the influence of this. So we have health stresses that play a role at the individual level, but that contribute, of course, at the health status of community. So in this project, we also include, to make it a little bit more complex, also what we call clinical decision support systems, that are clinical support systems that deal with these individual health situations. For example, a simple example is trauma. There is a module that tries to predict and to score trauma in a specific situation. So also at the individual level, you have a huge dynamic to be taken into account. Of course, we have to do this for the whole disaster management cycle. So we have the biannual core on a cycle, it's a community, whether it's a whole week, whether it's world level, for the different phases, phase of the medicine cycle, and different levels and decision making. We start and by the UK model and France, so practical teaching. So what we use to do health response of the health services is we make use of what they call the WHO family of classification. So these classifications, most of them, the most known is of course ICD, which is used in hospitals for people working with health sectors. That's a well-known classification system. So we base our taxonomy with respect to health impact and response of health services. We use therefore the ICD approach. If we look at the health issues involved in emergencies or in these extraordinary public health challenges, you have three major aspects. First, one has to do with clinical care, with health interventions for individuals. Another one has to do with health interventions on the public health level, on the population or collective level. And another aspect has to do with pure organization. So human and material risk management. So three main domains influence the approach that we have developed with IMPRESS. So of course in the healthcare, we have a huge number of stakeholders. The health, you can have a taxonomy, whatever you like. They have a lot of stakeholders involved. And you can characterize them with different methodologies, but you have the different stakeholders. Right, okay, thank you. And in order to deal with this, we try to link our decision support tools with a number of existing typologies, taxonomies, and existing databases. So we're not trying to develop databases ourselves, but with existing databases, for example, databases of emergency call catching centers. So we have, as a conceptual model, as a conceptual framework, extraordinary events leading to specific health impact, requiring a specific response of specific, and we link them with a number of databases that have information on all these aspects of the issues. So you have both positive and negative health determinants, you have an impact on the public health, and you have a consequence that is described by different words: disaster, mass emergency, mass casualty incident. All these terms are used in a very heterogeneous way and are badly defined, but we, with our generic model, we can try to characterize them more specifically. And then you have an impact on the public health, you have health interventions, and of course these health needs present themselves in a very specific way. Let me give you a simple example. You can have a mass casualty incident with 100 casualties. It's a very different problem if you have a bus or a train. For example, in a bus, all these casualties present themselves at once, or nearly at once, while in a train accident, before they're released, it takes them quite some time. So they present themselves bit by bit, person by person, because the entrapment is an important issue in, for example, train accidents. So the type of presentation is important with respect to the health needs. So in dealing with these challenges, we have 4 major types of taxonomies that we developed. One has to do with the etiological event, whether you call this a natural geophysical event like an earthquake. You can have taxonomies with respect to the health determinants, specifically health hazards, whether they are biological, whether they are chemical, whether they are pure trauma or mechanical, whether this is ionizing radiation. So we have taxonomies existing on these health hazards. And then you have a taxonomy of the health needs on the persons involved. Of course, for the same reason, you have huge type of taxonomies that you have to develop with respect to the resources and the activities in response to the health needs that they present. And we focus on the health sector, so we don't include the non-health responders. Of course, we know that is an interaction on the field with these non-health responders and these other emergency support functions. So while in the traditional approach, people focused on natural events like an earthquake leading to a natural disaster with damages and losses, with death and injury, we try to focus on the health impact only. So we have events which we can characterize by the exposure to different hazards, natural or human-made, that is irrelevant. So the classification of events as such is irrelevant only if they're relevant for the health profile that they produce. And then we have major incidents or public health emergencies as 2 major types of challenges. So how do we try to develop this decision support tool? So in order to develop this tool, it's of course necessary to understand the process. And what do I mean by the processes, the different processes? Well, one is the pathogenesis of disaster. Every disaster produces a specific health needs profile, or trauma profile, if you would put it simply. Every event has a specific time frame and different timelines that are taking place simultaneously. We have to identify the functional requirements and the key challenges involved. That means the dynamics of this proportion between needs and resources. We have to identify the information needs and to try to get adequate information. And we have to identify also non-functional requirements. Of course, we need to identify actors and stakeholders. Let me give you a simple example that worries a lot the people who have to develop the software. People assume that if you have a major accident, let me say that in Europe we don't have real disasters. In the last 50 years there was not a real disaster in Europe. We have major accidents. In these situations, we study, let's say, probably the most important, 50 most important major accidents. What we discover is that the patients are evacuated from the field within 2, maximum 3 hours. That we don't have that much insufficient resources, we have an overload of resources. And that a lot of these people who are on the field move themselves to the hospital. So all these structures, all these processes, all these command and control centers who think that they control the situation on the field, of course, are very much mistaken, because 80% of the patients move themselves to the hospital. So we have a displacement from pre-hospital to the hospital environment. Let me give you another example. Suppose you're involved in a bus accident and your child is injured. You will not be able to force a parent or a brother or a sister or a mother to abandon the heavily injured child and to go to a triage category of uninjured people. So you have a lot of factors that involve perceptions, that involve people who are active. So patients themselves, people affected, persons involved, neighbors, bystanders, they don't wait for somebody to command and control the scene, for somebody to set up a triage center. You must take into account that these people, of course, are very active. That is, of course, very difficult to take into account, but it's necessary to modify and to be a bit modest about the importance of the pre-hospital. That means that we have to go and to include the hospital as such, because a lot of the major incident problems go from the field to the hospital. So in order to have sources for decision support tools, we try to include a huge number of databases, a number of existing models and flowcharts, clinical data and available data in hospitals, but you haven't, well, you have to look a little bit at how Europe is in reality. We include people in Bulgaria. Of course, in Bulgaria, hospitals don't have electronic databases. They work on paper. In Belgium, of course, Belgium has a reputation of being a developed country. In our country, there is no real reporting being done. Medical doctors hate to record things. Electronic systems in hospitals are different from one hospital to the other. Standardization is unexisting. So how can you tap into hospital data if there is no standardization? And hospital data are very important because before you transport somebody, you have to know where to transport somebody. If you have heavily burdened patients, well, the exact place for a heavily burdened patient is a burn, an intensive care burn unit. So these burn units are very limited. So you have to know exactly where to transport the patient. You don't transport a patient who has to be operated for a neurotrauma to a hospital without CT, without imaging capacity, and without a neurosurgeon. So what we call the referral program from the field to the hospital, well, has to take information from the hospitals themselves. So taxonomy, we base ourselves on, as I said, the ICD and WHO family of classifications. And for the non-health issues, we use a standard that has been developed by the CEN, the Standardization, European Standardization Organization, which is, if you look at it, fully developed and which we need to improve. Okay, so to have an extraordinary response in these extraordinary situations, you have, of course, to build on routine health services. It's, of course, useless to build a system only to be used in these extraordinary situations or in major accidents or in disaster situations. You have to build on the routine health services. Secondly, you have to guarantee the business continuity because, well, there can be a major accident, a bus crash or a train crash or an airplane crash, but at the same time, people keep having their infarction or their stroke, so you have to organize business continuity of services independently from the event. And the problem is that if you have these accidents or extraordinary situations, there is no clear threshold, there is no real cutoff. You cannot say, well, starting from 10 patients, you have a major accident. It depends on the available resources and the dynamics of an event. So you have decisions that are both clinical decisions, public health decisions, and resource capacity management decisions. And for that, you have to develop a number of instruments. So let me take a simple example. This example is of a mass emergency, where there's a disproportion between the health needs and the health service capacities. So if you look at the chain of events, you can identify a number of key decision centers. The most important one is what they call the emergency medical call and dispatching center, where often the emergency call starts the whole process. This emergency medical call and dispatching center in major events, whether you call it disaster or major accidents, it's irrelevant, can lead to a crisis center, which is like a sophisticated, complicated emergency medical call and dispatching center. You have critical decision points on site, sometimes leading to what they call an advanced medical post or a casualty clearance station. You have medicalized transportation. You have the emergency department as a specific decision center, critical decision center, and of course you have the hospitals. And if you look at the information that is available, of course you realize at the beginning of an incident and on site the information available is very limited, it's very rudimentary, and that only at the discharge of the patient you have the full picture of the patient information that you need. So the disproportion that you have is a disproportion with respect to the numbers, mass, from there the word mass in a mass emergency, to the quality of the injuries. For example, it's very different if you have neurotrauma or burn injuries or just trauma, orthopedic trauma, to the time frame. So this disproportion has a number of characteristics, and they need to be dealt with by specific health disaster measures, additional mobilization, what they call surge operations, specialized teams in specific situations, or a more efficient use of the available resources. And you have a number of typical disaster health terms like NORIA, triage, medical regulation. All these things have to be documented if you want to come up with a decision support system. Similar. So if you want to study the process a little bit in detail, well, you have to go step by step and follow every logical order in the activities in the process that is going on. So in order to do that, we made use of a number of existing projects that already did this. And to document the emergency department patient flow, of course, also we can use existing systems that made an analysis of the flow of patients within a department. So we have an increasing amount of available information, but the most critical situation is, of course, pre-hospital. So the other side of the problem is what we call public health emergencies, public health challenges. Let me give a number of examples. Let's take a microbiological agent and an epidemic or an outbreak. Well, think of Ebola, Legionella, SARS, pandemic flu, and other emergency infections. You can also have what we call unusual or unknown toxicological symptoms, like the Balkan-Gol syndrome. You can have toxical infections. We in Belgium, of course, are confronted with this type of problems quite often because the Belgian state is rather dysfunctional. So we say in Belgium that if things go wrong in the world, they go wrong first in Belgium. So we were the first to develop a theory on public health crisis because we were confronted already in 1999. Because before anything was published in the literature on public health emergencies with the so-called dioxin and Coca-Cola crisis at the same time. You can have errors and defaults in consumer products, in medical devices, pharmaceutical products, and you can also have deliberate use of biological or toxicological or radiological agents, and so-called terrorist events or deliberate attacks. So the type of management of a public health challenge or a public health crisis is very different because you need other instruments: surveillance, exchange of information and communication, extraordinary decision-making, cross-border measures often, and control strategies. So it's quite a different approach than the mass emergency approach. So just to give you an idea about the type of incidents that are possible. You have here a list of new infectious diseases discovered between 1972 and 2003. If you think that Empress would be able to solve an issue like that, of course, that's extremely naive, because all these specific biological agents have a specific pathogenesis. So to think that you can come up with a solution that theoretically deals with this, but in practice would discover a new type of SARS or MERS, that of course would be a little bit pretentious. So let me give you one example of a public health crisis in order to give you some idea. So in 1999, something like half a bucket of transformated oil ended up in the food chain. 5 liters of oil ended up in animal fat. This animal fat ended up in fodder for pigs and chicken, led to an agricultural crisis, and then resulted in a human body burden. If you would have interrogated or read the press about these problems, you would find toxicologists, famous professors, estimating the human costs between 40 and 4,000 extra cases of cancer. So if you have to make decisions based on controversial interpretation and controversial data, that is of course extremely difficult. And if you look at the total direct economic costs of 5 liters of transformator oil leading to this problem, almost a billion euros because of this simple incident, which led to a public health crisis and also to the resignation of 2 governments. So the hospital is not only a critical decision point in mass emergencies, but it is a critical link with public health emergencies and response as such. So, in short, this is the architecture of the Empress project. One of the problems with this architecture is that the architecture was designed before the analysis of the problems were done. So users and people who made the assessment of the challenges involved were already confronted with the pre-existing architecture and the different modules to be developed. Furthermore, each of these modules was developed by a separate partner. So now, after halfway the project, after 1.5 years, what is the problem now? That people start only to realize that at some point they need to integrate, that at some point they need to talk to each other. And so we are involved with a huge problem of integration of the different modules. For example, we have Sikievo, developed by our Italian colleagues. These Italian colleagues are so ambitious that they think that they can develop a model to predict individual evolution of patients on the field. So if you think that you can modelize not only trauma, but also other types of hazards involving individuals, and that you can offer this model as a decision support tool for first responders, but the least you can say, it's very ambitious. So, and we have to integrate this in the decision support tool that we otherwise have. We have Logivo, which pretends to be able to develop a model for the logistics needed pre-hospital and in the emergency department. Can you imagine the challenge if you keep the scope so wide that you cover both public health crises and major disasters? You have a module called SORLOG, which is developed by Public Health England. Of course, a very logical model, but it's only capable of developing prediction of possible source, location, and possible time frame for exceptional biological agents. And they're only capable of doing it for 2 agents, which is anthrax and pestis. So you think, how can you integrate a device like that into a broader decision support tool? And then you have WASIS, which is a database structure claiming to be able to incorporate all possible data from different other databases and to present this to operational people. And then you have INSIMOP pretending to help people on the field with INSIMAC devices that would offer people on a mobile phone or on another device to offer support that is developed by the different modules. So if you see the challenge that we made for ourselves, I think we must be very realistic and limit the scope of the project. And that's what we're doing for the moment. We are narrowing down the scope of the project to a simple mass casualty incident, where you have, of course, different emergency support functions involved, where you have a command structure that is very theoretical and developed by the Americans following the incident command structure, where we have people responsible. You imagine medical people are not uniform people in uniform, so they accept very difficultly, with a lot of difficulty, somebody giving them orders. So to have a medical person in charge of all other medical persons, it's quite a challenge. So, and then we would be able to have at least a device that would help them making a number of decisions, especially decisions with respect to triage, which is a rather straightforward process, and decisions that have to do with evacuation of patients. Okay, I will not go through the details of the workflow of triage. I will end with the example that we are going to develop. So, let me skip a couple of slides. So, the test scenario that we are going to develop, and which will be limiting the developments of the software that for the different modules, is an earthquake scenario in Bulgaria, where we have a specific trauma profile that we developed, namely the trauma profile that corresponds exactly to the 99 Athens earthquake, causing 143 deaths, 750 injured, a number of people trapped, a number of people homeless. So we think that in order to be realistic, Impress can develop a decision support tool for this type of scenarios based especially on trauma. So what could Impress try to offer? They could try to help making decisions in the operation center or the emergency medical dispatching center, try to help with how we make alerts of medical responders, how to set up on-site medical infrastructures, how to activate incident command systems. In this Bulgarian-Greek scenario, we also need to mobilize the European civil protection mechanism because we have a cross-border problem. We will involve other relief agencies, and as a matter of fact, our ambition will be limited to resource management and to offer a minimum of common situational awareness. So this is the limitations that we impose on self based on the use case scenario. So realistically, what can we expect probably from Impress is help with coordination, help with the situational awareness through information exchange, try to have management of resources, help with triage and with referral, try to implement dynamic incident command structures, try to limit the span of control, help with patient tracking and through using smart mobile applications. We have a crowdsourcing app that will be integrated also in this support tool, and we'll have other various decision support tools where we will limit the ambitions of these individual models. Okay, thank you very much. So, of course, everybody has the opportunity to write to Impress or to myself for more information on more clarification on a number of issues that I raised. So maybe.
Thank you for your presentation. Are there any questions?
I have a non-technical question.
Yes.
But it seems that it was a very pluridisciplinary work and project.
Yes.
Yes. So you as a doctor, how have you interacted with the other fields? Was it easy, simple? And, how it impacts the project?
Well, there's the joke about the medical doctors, of course. If you have two medical doctors together, you have already 3 opinions. So within the health sector, there is not a standard approach of these health issues. Secondly, before we do the analysis, we talk with a lot of people, but of course, not every medical doctor has a strategic vision. So many health professionals, their knowledge is limited to what they do on a daily practice. So they don't ask themselves wider questions or operational questions that have a higher level. So in order to solve these issues, in order to do an analysis, you need people who can think strategically. And then the second problem is the one we already raised. How can you communicate the needs that you see to the IT people? Also given the fact that every partner already knew before they started the project what they're going to develop, because each partner already bases his research on existing tools. For example, there's a partner who already has an emergency call and dispatching resource management system. The only thing he's interested in is making it adapted to a mass emergency. Others have already clinical decision support for trauma. The only thing that we're interested in is developing it for a mass emergency situation. So every partner thinks for his own module, and of course now we are faced with the problem of integration. So facing that, well, or you become cynical, or you try to become an educator, or you continue to discuss. But I have not given enough hope that maybe at some point we will come at some common view. But it's of course what I described is it's a very difficult process, a very difficult situation.
And linked to this question, to have a common view, as you said, sometimes from a technical point of view, we use what we said ontology.
Yes.
You spoke about classification, but I didn't see ontology. So
well, we had discussions on this, the exact signification of taxonomies and ontologies, and based on the taxonomies that we develop, we are now trying to develop a common ontology. So this is the process for the next months, and maybe I can be able to present you the results in a year time or so, something like that. Because that's of course the approach that we decided to come up with.
Okay, thank you.
Thank you very much.
Other questions? Okay, thank you. Yes.
Yes. Yes, I just wanted to ask that during a crisis or emergency, I can say, there is always a discussion that if we use this kind of centralized programs, decision support systems, are they efficient as the not centralized decision support system works?
But not only that, we have stakeholders meetings with users from the pre-hospital. A couple of them had said, who are leading these emergency medical services, that they will forbid anyone, an ambulance paramedic, or a medical doctor in the field, to use any IT device, because the use of the device as itself distracts from their core mission, which is taking care of the patient. So, of course, this is an extreme point of view, which formulates the core business that they have to deal with, which I, of course, can understand. But I think there are some possibilities. One of the possibilities is the development with wearables and automatic devices. I think that there's a number of possibilities with automatic devices so that people on the field don't have to put in data themselves, and which would distract them from their core mission. So I think that one of the key questions is, of course, that medical people on the field have no idea about what is available or what is possible. With respect to the command and control structure, well, I think that there's a huge autonomy in people making decisions, and that the only thing that you could do is offer them a number of possibilities, a number of options, because in crisis situations, often people jump to conclusions, and that only the fact that you have a number of options presented to you as possibilities would be an interesting choice. But, of course, impose a decision on somebody on the field or in the health services is, of course, impossible. So you don't have a really centralized command, but you have a centralization of data which you can offer as a possibility, present to them as a possible option. That's the choice that we need to develop.
Okay, thank you.
Thank you.
Other questions? No? Thank you again,
Thank you.
Jules. Now it's time to the closing session.
We'll wait a few minutes for this. Come on, Norges, we have to close the session.
Yes, I was calling for the remaining organization members to let them at least be with us for the closing. Behz. Behz. Fadwa. Bravo.
Okay. Ladies and gentlemen, it's time to close the second edition of the Scrum MED conference held in Tunisia. We would like to thank a lot of persons and groups. We'll start by the organizing committee. Please, if you can stand up. The organizing committee. Yes. The works supervised by Narges, so we have to show the Narges all the work done. I would like to thank especially coming from abroad, because the events couldn't happen if you were not here. So I'd like to thank you very much. Those coming from France, from Norway, Italy, Spain, so on. Congratulations. And now I give you the microphone.
Thank you, Shihab. I will again and join Shihab to thank all of you who helped by contributing, by coming, by discussing, by getting this edition occur, and
be a success.
Be a success, yes, I should say. I hope that it is a success. And also, a special thank for all those who helped directly or indirectly, maybe absent or present, and special thank for some members of the local organization team who helped a lot. I hope that they enjoyed. All of us, we were learning a lot by organizing and hosting. It is a really great pleasure and honor to get you with us. And the very big thanks for Shihab, who encouraged me last year to go, let's go, and you will participate. And as I said, we have earlier collaboration, and for example, with Serge, with François, with Shihab, we've already collaborated before meeting each other many years ago about these themes and so on. It was really an opportunity to meet. With Serge, we have already, don't know, I was helping by NPC member in co-chairing with my session and so on. It's really the community where really living this event, growing and getting connected more and more. I hope it is a beginning that we will continue to travel, to go and to travel over Mediterranean Sea countries. And now, as final, how to say, petit geste de notre part, is to let you a small souvenir from Tunisia. Present, and here Marwa and Fadwa can give to the authors who were present with us and presenters, all those who have presented their papers here, the certificate, participation certificate, and a small gift from Tunisia to pack with you. And thank you very much.
For next year, we have some contact to organize, but it's not sure, the conference abroad in Europe. It couldn't be in France, because it has been in France last year. So we make a call for proposal, but if some of you from your team would like to do it in a Mediterranean country, host it in a Mediterranean country, you are welcome.
Also, perhaps we may think for the years after the 2016, 2017, and so on, with the aim to alternate North and South from Mediterranean Sea to travel, it will be a really nice opportunity. So please, if you know other people, potential contributors for the next year or the year after, it will be nice to begin thinking. Perhaps we will have other things. And for myself, I would be really happy to receive your suggestions, remarks for improvement. Also at the scientific as well as the organizational level, what do you think about how to get better involved and attract more people, all your remarks are welcome to improve and to get this work and this young conference gets bigger and this network gets bigger. Thank you.
Yes. If some of you would like to make a remark or something like that, do not hesitate.
Okay.
No? Okay, so the second edition of ISCRAM MED is closed now.
Serge, vous avez aussi votre facture. Vous devez signer.
Ah, je dois signer quelque chose. D'accord. Merci.
Il est présent.
All those who have presented the paper have received the present.
Ask for your present. If you don't have one, please ask. Email. Et maintenant, il faut aller peut-être s'approcher du restaurant.
For the luggage, can we take them from the
We will
rooms
eat
after?
and, yes, I think so.
No problem.
Please ask for your lunch ticket if you don't have one. And let's go to
When we create the Facebook events, that some photo or something to share, and I will do it on this Facebook page. I'm gonna put the link on the Instagram website. Yes. Okay.
And also, I will be pleased from all those who make presentation, it would be nice to share them with us, to send us the PDF as soon as you can, and put all this on the website, the program, and the PDF presentation. Sorry?
Tu peux le rentrer.
Bien sûr,